5E. This is on page 92. At the university, in example 10, one applicant scored 750 on the math SAT. She was at the blank percentile for the score distribution. So we need to draw our normal curve. What is the average from example 10? 535. And what's the SD? Equals 100. So we want to know if a particular person scores 750, which is over here somewhere, what is their percentile? Well, I need to turn 750 into a z-score. How do I do that? I do 750 minus the average, 535. Why did I do it in that order? I need the answer to be positive. How come? We're to the right of the average, so my z needs to be positive. Okay. What does 215 tell us? That tells us that this person scored 215 points more than average. Okay. So I need to turn this into a z by dividing by the standard deviation. And what does that number tell us? Good. 2.15 SD is greater than average. What do I do with that number? I'm going to shade norm and calculate this area, which will tell me the percentile. So clear out my draws. I wish my calculator was as fast as a normal calculator. Isn't it weird? My big fancy computer is slower at running the calculator software than the calculator is. So from negative number up to 2.15, comma 0, comma 1. And I end up with 98.4%. Why does that sound reasonable? How do I know that's probably correct? Just by looking at it. It is a large portion. If I were to go out to z equals 2 and z equals negative 2, I would capture 95%. So there's 95% here, and then I add a little bit on this side, and I add a little bit on this side. 98.4 sounds about right. Okay. Number 2. Wait a minute. Am I on the right page? I'm not. Okay. For the university in example 10, estimate the 80th percentile of the math SAT scores. So I'm actually just going to go back here and use this same picture. All right, 80th percentile. Where on the curve would you find the 80th percentile? To the right of the average. Because the average is always the 50th percentile, as long as the curve is normal, right? The median is the 50th percentile, but if the curve is normal, the average and the median are in the same place. So this is the 80th percentile. And I want to know, what is the score for the 80th percentile? This is a little bit tricky. How should I start? And we're going to do this a lot over the course of this class. Good. So this area is 80%, which tells me the other side is 20%. So this over here is 20%. And if I do the same thing on the other side, and I knock out 20%. That tells me that this central area is 60%. How does that help? Now I can look up the z-score from our yellow paper. I go to 60% and it's 0.84. So z equals, is this a positive z or a negative z? Positive, how come? We're to the right. So 0. What was it? 884? Let me double check that. Yeah, 0.84. Okay, how does that help? Well, interpret this. What does 0.84 mean? The person in the 80th percentile is 0.84 what above average? SDs above average. So I need to I need to change this from SDs into test points. How do I do that? Multiply it by the SD. So I'm going to times it by 100, and that gives me 84. What does that number mean? This person scored 84 points higher than average. So to find the score, I take 535 and add 84. And I get 619. Okay? And that's pretty much how this class works from now until the end. Chapter 5 is pretty much it. Now we're going to get into some other stuff like combinations and some other things. But basically, this is what you need to be able to do until the last day of class. Can you take a score and calculate an area? And can you take an area and calculate a score? All right, number 3. For Berkeley freshmen, the average GPA is around 3. The SD is about 0.5. The histogram follows the normal curve. Estimate the 30th percentile for GPA distribution. So my average GPA is 3, and my SD is 0.5. And I want to know, what is the 30th percentile? Where is the 30th percentile? It's to the left of 3. So I want to know what z-score, well, what value, what GPA gives me 30% area on the left. How am I going to calculate that? Well, I need 30 on the other side, which gives me 40 in the middle. And I look up 40 in my table, and it looks to be 0.52. So z is equal to negative 0.52. Does everybody understand why it's negative? All right. Now, what does this tell me? The 30th percentile is 0.52 SDs less than average. But I don't want to know how many SDs. I want to know their GPA. Multiply by the SD, and that will convert my SD into GPA. Well, GPA points, I guess. So negative 0.52 times 0.5 is negative 0.26. What does that tell me? That's how far below the average GPA we are. So I take 3 and I subtract 0.26, and I get 2.74. So a person with the, oh, look at that. That's creepy. A person with the GPA of 2.74 is in the 30th percentile.